Hello everyone, my name is Prashant Mohan Thakur and I welcome you all in yet another video in the series of CAT 2023. So today we'll be doing on video on LCM. In our last video we did on HCF, and in our upcoming videos we'll correlate LCM and HCF both. Okay, so this is in Competition Valley. You can refer to all our previous videos on our channel Competition Valley, and so let's begin today now. As the name suggests, it's lowest common multiple. So first we will see what we have been doing. That will set up our base, and then we learn the concepts. So let's say if we need to take LCM of 2 and 4 for an example. So what we used to do as a child, we used to do something like this. 2, and then we used to do 2 into 2 into 4. Okay. Now if the same thing, if I had to take, let's say for 4 and 6, so again the same process we would repeat. So 4, 3, and we will do 2 into 2 into 3. So it makes 12. So this is how we have been doing. We can do one more so that we understand what we have been doing and how we have been doing. So we used to do something like this. So 2 into 3 into 4. Okay, now this is what we have been doing. Okay, but now in CAT 2023 or in any other such standard examination, we can't do this because again these numbers won't be as simple. So we have to find a way, and it won't be anything new. What we have been doing will be just changing the way of looking at it. The process does not change, it remains the same. So let's begin. Now we know, because in our last slide we calculated this to be as 4. So how it has come? Okay, we forget about that method what we did. Okay, just try to create a new aptitude for this. See what we have done over here, that we have read the table of 4. Okay, so when we read 4, we said 4 into 1 is 4, and now we checked if 4 comes in table of 2 as well. So 4 is a factor of both. Okay, and 4 is such lowest number. You know, you could say that 8 is also factor, 12 is also factor, 22 is not 24 is also factor, but we need to find the lowest one. So 4 is such a number that would be in table of 2 and 4. What it means is it will be a factor of 2 and 4 both, and it's the such smallest number. Okay, similarly when we are calculating for 4 and 6, read the table of the bigger number and find the number that would be available in both these numbers. So let's say 6 into 2, 12. Now 6 into 1, 6 would not, because 4 and 6 would not come in table of 4. So 6 into 2 is 12. So 12 is 4 into 3. So we can say 12 is our LCM. Similarly 8 and 6 again. So read table for 8 now. So 8, 1, 8, 2, 16, 24. We will find that 24 is factor of both 6 and 8. Similarly, you can calculate LCM for any number. Basically, these would apply for smaller numbers where you know the table and where you know straight away what number will fit in. So you can say, let's say if you want to do it for, let's say 15 and 45. So again, read it for 45, 45, 40, 90. 90 is 15 into 6. So what we are doing is, in method 1, I would say, or in method 1, what we are doing is we are reading the table of large number or larger number in the given question, and that's how we try to fit in the number, the number that we are reading. We try to see if that number is on the smaller number as well, whatever we are getting over here. Okay, any number you can say for, let's say 22, and we can say whatever number you can say let's say 22 and 44. If I take, so it will be 88. No, it will be 44 itself. Why? Because 44 into 1 and 22 into 2, so it will be 44. So without even using a pen, you can easily find this. So this is step number 1. That's what we have been doing. Now there are certain other methods as well. I'll just tell you about that. So this is co-prime method. This we have studied in our HCF as well. So we'll be using that in LCM as well, but slightly different. Okay, so let's say we have to find, let's say for 15, and we can check for 15 and 20. Okay, so can we write 15 and 20 as 5 into 3 and 5 into 4? Can you write this or not? See, this is common and these are co-prime to each other. As we studied in our last video, co-prime means that there is nothing common. Only the number 1 would be common. Apart from the number 1 itself, there would be nothing that would be common. So if we had to do the HCF, if HCF for this pair would have been 5, but for LCM we are going to do 5 into 3 into 4, so it will be 60. Okay, you can check this with any number. You can check this for, let's say, 66 and 77. So we know 11 into 6 and 11 into 7, so it will be 11 into 6 into 7, which is 11 into 42, so 222, 44, 46. So this is method number 2. Okay, so this is co-prime method. Now we will see the concept. Okay, we'll learn a concept from method 1, and we'll try to see if we generalize it, where does it go. Okay, now let's say if you were asked this thing, that find the LCM of this particular number. So this number looks very huge, so we cannot go the method number 1 or method number 2. We cannot do anything. If you start doing that way, it will take a lot of time. So remember, the concept here is that LCM is always the highest, again remember, highest power of any prime base. Okay, so now we see over here that in 2, highest is 2 to the power 7. In 3, it is 3 to the power 12, and in 5, it's 5 to the power 7. So our LCM would be this. This is our answer. Okay, we'll do one more question. So again, what would be LCM? LCM always takes the highest power of prime base. So what it would be? The LCM would be 2 to the power 6 into 3 to the power 8 into 5 to the power square, 5 to the square. Okay, now we'll do another concept. Now see, these are the numbers. Okay, now LCM 1 2 1 2 3 4 5 6 7 8, we have tried going over here, but we can go as far. Okay, I've just limited myself over here so that you can, by the time we reach over here, you will understand what we're trying to learn from here. Now LCM 1 and 2 is what? 2. Very simple. Okay, LCM 1 2 and 3 would be 6. Now LCM 1 2 3 4, in any idea? 1 2 3 4, so it will be 2 1 3 2, so it will be 3 2 6 to 12. Now I'll tell you, you can do this without using your pen as well. Okay, that's not a difficult thing. This would be 60. Again, this would be 2 to the power 2, so it will be 5 2 to the power 2, 2 into 2, so this should be 60 as well. This would be 420. Again cube, this would be 840. Now how did I find this, and how can anyone find this just by using mentally? You don't have to use your pen. Okay, so that's what we are supposed to learn. Now see over here, in 1 2, okay, it's very common too, so we can start from here. Okay, nothing much over here. Now in 1 2 3, you see, we know the LCM of 1 and 2. We know the LCM of 1 and 2. So simply we are multiplying 3 over here. So this is what we are getting, 6. So what we did over here, LCM of 1 and 2 multiplied by 3. Now this is what we are doing right now is very, very important. There are so many beautiful questions that we will be doing afterwards, in fact in this video itself, so you just understand what has happened. Now in this thing, you may say that okay, 1 2 3 is 6, and why not 6 into 4 is 24? Why is 12? Now if you look at this, if you look at this number very carefully, See, in 1, 2, and 3, what has happened? We had 1 and then we have this 4. What is 4? In 4, we already have 1, 2. In what? So we had this 1, 2, and 2, 2. 4 is 2 into 2, 2 square. So we in 1, 2, and 3, we already had this 1, 2 available. So how many 2's are we adding up? So we just are adding 1 to this form or to this question. So therefore we are multiplying it by 12. I'm sorry, we are multiplying it by 2 because we are just adding one number, that is one extra 2 is being added. So what we are doing, we are multiplying it by 2. So we are getting 12. Now again over here 5 has not been in this series 1, 2, 3, 4. So we are adding 5 in this series. So we are multiplying the x by 5. So 12 into 5 is 60. Now again you may say, then why is 60 over here? Okay, it's very simple. Again, look over here. What are we adding over here? We are adding 6 over here. What is 6? 6 is nothing. 6 is 2 into 3. Now do you see in our previous form we already had this 2, we already had this 3. So we have not added anything new. Okay, it's just same thing. Okay, it's just we have, although the number 6 is appeared, but even though this number can be right is the existing number over here because it has everything. 6 is what? 2 into 3. So it's already there, 2 into 3. We have already calculated this. Therefore, it will be 6. And you can calculate it. 1, 2, 3, 4, 5, 6. If we do so, 1, 1, 2, 5, 3. Again, if I want to do it 3, 1, 1, 2, 5, 1. So how much? 10, 30, 60. So we are getting 60. Now in 7 over here, we are adding another 7. There is no 6. I'm sorry, it is only up to 6. There is no 7 over here. So we are adding 7. So therefore we are multiplying it with 7. We are adding 7 in the series of the question. Now in 8, see, what is 8? 8 is 2 into 2 into 2. Over here, what is the maximum value of 2 we have? We have 2 square, which is 4. And look over here. We just have, what is the highest power of 2 over here? Highest power of 2 is 2 square. How many 2's do we need? How many 2's do we need? We need one more 2. Why? Because 8 is 2 into 2 into 2. So what we need is, we need to take care of this extra 2 as well. So what we have to do, we have to just simply, we have to multiply it by 2. And you can keep going this way. Okay, this will be very important in upcoming question. But understand once again. 1, 2, we know LCM is 2. Okay, in 3, we have what we have done. We have added an extra number. Okay, 3 is not above here. So it's going to be 6. Now over here, 1, 2, 3, 4. So over here, the highest power of 2 is what? Highest power of 2 is 1. But now we have a number which is exceeding that. So it's exceeding by 2. So we have multiplied it by 2. Again, 5. There is no 5 on the above number. So we can multiply it by 5, 60. Again, over here we have 6, but 6 is what? 2 into 3. Over here, what is the highest power of 2? Highest power of 2 is 2. So there is nothing new number that we have added because 6 is 2 into 3, which is already present over here. So this is 60. Again, by 7 we are multiplying because 7 was not present earlier. So 7, 420. And that's how we calculate LCM. Now this is an application that will be utilized in questions that we'll be doing ahead. So better take a minute, look at this format, what has happened, and try to do for 9 and 10 and 11. Maybe then you would understand what I'm trying to tell you. Now I'll just do a question, like not just one, couple of questions, so that you understand what has happened. Okay. Now again, it's a very beautiful question, very conceptual. I've already explained you this concept in last slide, but okay, that's okay. If you have not understood it, we'll do it question and then maybe you can understand it. Okay, it's a very, very, very good question. If you can understand it, it's not going to take you a minute, but if you have not understood it, it may take as long as possible. So we'll try it. Okay, now say the question says that LCM of, let's say 1, 2, 3, 4, 5, 6 up to 56 is n. And we need to find LCM up to 59 in terms of n. So let's say if it is n, so it should be 4 and 5 and 6 and anything in terms of n. Okay, we don't need not to go for an exact number. Okay, so again, I'll just rephrase it. So 1, 2, 3, let's go up to 56 is n. Now understand over here what the question has given. Okay, let's try to break it. Now it says that the number is up to 56. Okay, so it would have all those numbers up to 56. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 50, 51, 52. It would have every number up to 56, and the LCM for all these numbers is what? N. Okay, now what do we know? We know that LCM takes the highest power. Do we know or not? Of prime base, isn't it? Very clear. We have studied this. Okay, if not, we'll again study. We'll do some questions on to this as well. But this is what we have studied before. So can we write this as something like this? Can we write n as 2 to the power 5? Why? 3 to the power 3, 5 to the power square, 7 to the power square, 9 we don't need it, so that's where we can stop. Why don't we need 9? Because 9 to the power 1 it would be. It won't be more than that. 9 would be only, we don't need 9. 9 is not a prime. So 11 we don't need it, and 13 etc we don't need it. Okay, now how this has happened, just focus. Okay, the maximum value of 2 is 5. What it means is that why not 2 to the power 6? Because 2 to the power 6 would be what? 64. We don't have space for 64. Okay, we have only limited ourselves. We have to find up to 59. Okay, so the maximum value of 2 can be 5, which is 32. 3 to the power cube, what it would mean? 80, 27. Why not 3 to the power 4? Then it would be 81, but we don't have space for 81 because we just need to find up to 59. Okay, similarly 5 to the cube would have been 125. Again, we don't have space for that, so 25, that's the height, and 7 is 49. Okay, why don't we go for 11? Because 11 to the square would be 121. We don't need it, so it will be just 11 to the 1 and 13 to the 1. We can go as far. Now any prime number you can take. That does not help us. Okay, now see over here again. So first understand once again. I'll tell you what we have done. We have broken this thing into entire prime bases as far as we can. Okay, so 2, the highest power of 2 would be 5, simply because we don't have space for 64. 2 to the power 6 would be 64, but we only have number up to 32. Above that we can't go. Similarly 3 is 27. We can't go above that because then it will be 81, which we don't have to go for. And similarly 25 and 49. This is the first step. Understand this. If you have understood this, then it is very easy for us to do. Okay, so I'll just rub this off and then I'll start again. Okay, so now let's start like this. LCM of 1, 2, 3. If you go up to 57, so what is 57? 57 is a prime number. Okay, so again, as we studied before, let me go up to this. So LCM up to 56 is n, and this is a new number that we have added, and 57 is nowhere because this is a prime number, so it would not be in the series of 1 to 56. So we can simply write n into 50 n into 57, so it will be 57n. Okay, now let's go to 58. LCM, if I go straight away, if I write 57, 58, let's say if I go for 57 and 58. Now 58 is what? 58 is 2 into 29. Already we have 2, already we have 29 over here. So LCM would not change because 2 and 29 both have already, we have calculated. See, in this series, n is a LCM, so n has taken everything, 2, 29, everything up to 56. So it will be still the same, 57 n. Now we need to go to 59 again. LCM of, we'll go this 57, 58 and 59. Okay. Okay. Oh, there's some mistake. I believe 57 is not prime. Okay. So still it would be the same. 57 is not a prime number. So I'll just start again explaining this. So LCM is n up to 56. Now we have added 57. 57 is nothing. 3 into 57 is 3 into 19. So it's already there. So it would be n. Again 58, it's still 2 into 29. It's already there. So still it would be n. Now 59 is a prime number. Okay, 59 is a prime number. So 59 has never been into this series. So it will be 59 into n. Therefore, the answer would be 59 n. Okay, just look at this. We'll do another question. It was a mistake over here. It's very simple. See, LCM up to 1 to 56 is n. Okay, understand this. Now we have the next number is 57. 57 is what? 3 into 19. And what do we know? We know that we have already broken this into prime bases. In prime bases, we found it to be 2 into 5, 3 into 3, 5 into square, 7 into square, etc. So it's already there. 3 is already there in this series and 19 is already there in the series, which makes 57. So the prime number, so the LCM would not change. By addition of 57, LCM would not change. Same with 58, LCM would not change because 2 and 29 both are already present, and we have already, the n is LCM of everything, 2 and 19 as well. But with 59 it will change because 59 is a prime number. It has never in any way, it has never been expressed in the given series. Therefore 59 is a new number, so we have to multiply it with n, and 59n is our required answer. I'll do another question. Okay, now see the similar question. LCM is up to 1 to 78 is n, and then okay, so we'll just rewrite this. LCM of 1 2 3 up to 78 is what? N. So if I want to break it to the prime factor, see 2 highest power will be 6, which is 64. 3 we can't go 3 because again it will be 81, but we can, it's already given over here, so we can go for 27. And then 5 square, 7 square, 11 into 13. Why up to 13? Because 13 is a factor of 78. Okay, now from here we'll derive LCM. If we want LCM 1 2 3 78 and 79, what it would be? Now again, 79 is a prime number. Okay, so up to 78 we know it's n. Now addition of a new number in the series, so what are we going to do? 79 into n. Okay, understand? Now second, LCM 1 2 3 78 79 80. Now 80 again we have added. So what is 80? If you want to break it, 80, so 80 is what? 10 into 8, so it's 2 to the power cube. Okay, 2 to the power, oh I'm sorry, 2 to the power 4 into 5. That's what it is. We see it's already there. 5 is already there and 2 to the power 4 is already there. So it means we have already calculated the LCM 80 before when we are doing it in the 78. There is no new number that is being added in the series, so it will not change. So this LCM would still be 79n. Now again we go for 81. 81 is what? 3 into 3 into 3 into 3 into 3 into, so we have, see over here, 3 cube is already there. So how many 3's are we adding now? We are adding one extra 3 is being added. So what would be, how much the LCM would change? 79 into 3n. So it will be 237n. Now for, if similarly if we go for calculating up to 82, what it would be? 82 is what? 2 into 41. So we have already done 2, we have already done 41, so it's not going to change. So still it will be the 237n. This is our answer. Okay, 237n would be our answer. Just see what has happened. I'll do another question. We'll do ample question so that you understand every topic. Okay. Okay, now you can do this question without taking your pen as well. You can do it simply. Okay, so it's 1 2 3 up to 96. LCM up to 96 is n. Okay, now the next number would be 97. 1 2 3 96 97. Now we know 97 is a prime number, so it is n, so it will be n into 97. Now 98 is what? 98 is nothing but 49 into 2. 49 we have already done over here. 2 we have already done, so it's not going to make any changes. Okay, and LCM 99, again we have already done 3 into 33, which is 3 into 3 into 11, 9 into 1, which is already 9 into 11, which is already done over here. So it's not going to change anyway. So it will be 97 and still, and 99. For 100 again it's 25 into 4, so it's 5 to the square, which is already over here, and 2 square, so it's already there. So for 100 no changes, so 100 would be 97. The 101 is a prime number, so it's going to make changes. So 101 into 97, and this is our answer. Beautiful concept. can be done without any effort. Okay, just look at it, what has happened. Now if you have understood these, it is very easy for you to do it. Okay, so now we'll just see what we have done in this class and what we are going to do in the next one. Okay, so this is what we have learned today. We have learned how to calculate LCM by the use of co-prime method, and then we have also seen how we can do, like, we know 1, 2 and 3. If we know the LCM, we can do it 1, 2, 3, 4, or 1, 2, 3, 4, 5. So without using pen, actually we can see how LCM can be derived. And then we also did some good question on this concept where LCM takes highest power of prime number, and using this concept where what we studied in previous slides. So this is for this video. In next video we will be studying relations between HCF and LCM, and then we'll be doing some lovely questions and some brainstorming questions on LCM and HCF. Okay, till that time, enjoy watching the video, learn something new. If you like it, please share it, subscribe it, do leave your comments if you find anything that you have not understood, and take care of yourself, and all the best. Bye.